MYP3 Unit 2 Chapter 6 was all about units of measurement. It's just talking about the difference between units of measurements for lengths in one dimension, so such as centimeters, meters, kilometers, areas in two dimensions, so they're in centimeters squared, meters squared, kilometers squared, and then volumes for three-dimensional things which are measured in centimeters cubed, meters cubed, kilometers cubed. A little bit messy there. I think I've got a volunteer to do it on the board during the lesson. And then litres, that's also another unit of measurement for volume. 1 litre is 1,000 centimeters cubed. So I gave a question, a certain maths teacher filling his swimming pool as if with 25 centilitre water bottle, so a whole swimming pool which is 5 meters by 6 meters by 7 meters, filling it up with 25 centilitre water bottles. How many trips will he need to make to the tap in order to fill the pool, bottle by bottle? So the problem there is a couple of things, the different units that it's expressed in, so meters for the dimensions of the pool, but centilitres for the bottle. And then you've got to bear in mind that although 1 metre is 100 centimetres, a metre cubed is not 100 centimetres cubed, because a metre cubed is a metre one way, a metre another way, and a metre another way. We'll talk about that a little later on. So, when we are faced with a problem in a variety of different units, centimeters, meters, liters, milliliters, centiliters, etc., it's a good idea to convert everything into the appropriate units before we start calculating. So whatever you want your final answer to be in, I recommend that you convert the units first before you do any calculating into the ones you want the answer in, and then figure it out, rather than try and work out the answer and convert the units at the end. And then we need to be particularly careful about whether we are dealing with units of length, area or volume. For example, as I said earlier, a metre is 100 centimetres, but a metre cubed is not 100 centimetres cubed. And here's why. Because a metre cubed is a metre by a metre by a metre in 3 dimensions. 1 metre is 1 metre times 1 metre cubed. It's 1 metre times 1 metre times 1 metre. And then if you convert all of those 1 metres into centimetres, then you can see that it's 100 centimetres one way, 100 centimetres another way, and 100 centimetres in the 3rd dimension. So a metre times a metre times a metre is 100 centimetres times 100 centimetres times 100 centimetres, and that gives you 1,000,000 centimetres cubed. So 1 centimetre cubed, 1 metre cubed I should say, 1 metre cubed is 1,000,000 centimetres cubed, not 100. So 100 centimetres in a metre, but 100 times 100 times 100, 1,000,000 centimetres cubed in a metre cubed. So if you had a box that was a metre by a metre by a metre, and you were trying to fill it with dice that were a centimetre by a centimetre by a centimetre, you'd need 1,000,000 of them to fill it, and not just 100. Similarly with areas, 1 metre squared, so a metre squared is a metre by a metre in 2 dimensions. So that would be the same as 100 centimetres times 100 centimetres. 100 times 100 is 10,000. So 1 metre squared would be 10,000 centimetres squared, and not 100. So this is why I recommend changing the units first, because if you have got a mixture, trying to figure out how many zeros in the final answer at the end is a lot harder than just changing the units first into whatever you want it to be, centimeters or meters, whatever. So, back to my problem about the certain maths teacher. So, a 25 centilitre water bottle and 5 meters times 6 meters times 7 meters for the pool. Now, I happen to know that 100 centilitres is 1 litre, so 25 centilitres would be 0.25 of a litre. So each bottle is 0.25 of a litre. Now the pool is 5 meters by 6 meters by 7 meters. If I convert that to centimeters, that would be 500 times 600 times 700, which is, I should have put this in standard form, shouldn't I? 210 million centimeters cubed. And I happen to know that 1 litre is 1,000 centimeters cubed, so that would be 210,000 litres. So I've kind of put everything into litres, and to help me do that, I put the meters into centimeters first, so I could work out an answer in centimeters cubed, because I knew how many centimeters cubed there were in a litre. So I've got a pool that's 210,000 litres. I'm filling it with bottles that are 0.25 of a litre, so the number of trips will be 210,000 divided by 0.25, which is 840,000 trips with the water bottle to fill up the swimming pool. So here's another thing we did. We measured the floor of the maths room as being 8 by 7 meters, and floor tiles are 25 centimeters by 25 centimeters. How many tiles do you need to cover the floor? So problem there being that you've got a mixture of centimeters and meters, and you want to decide which units you're going to work in and put it into those units first. So the room was 8 meters times 7 meters. I've converted that to 800 times 700 centimeters, which means that the area of the room in centimeters squared is 560,000. The area of a tile is 25 by 25. 25 times 25 is 625 centimeters squared. So the number of tiles is the area of the room in centimeters squared divided by the area of each tile in centimeters squared, and that comes out to be 896. So 896 tiles to cover the maths room floor, assuming of course that you can fit them all in, and 20 blocks of 25 centimeters will go into a meter, so we should be able to tile it with 896 tiles.